Okay, alrighty. Well, we'll go from here. So good evening, everyone. And definitely, I think a round of applause there for Kevin and Bill for getting everything set up here and getting everything working. So very good, guys. And very good evening to you all. My name is Andrew Jim Danielson, AC9EZ. I'm located in Fort Wayne, Indiana, right there in the northeast corner of Fort Wayne. I want to give another thank you to Bill for kindly inviting me to come and speak, as well as to Kevin for his technical expertise here and getting everything all arranged and set up. Also, definitely want to thank my mentors, Dr. Jordan Marshall, November Mike 9 Lima, and Dr. Scott Bergeson, both of Purdue University, Fort Wayne. Without them, this project and eventually this presentation would not have been possible. So definitely appreciate their assistance. And I also have to give a thank you to the PFW Honors Program, Director Farrah Combs and Assistant Director Rachel Gibson kindly gave me a scholarship to help purchase supplies for and equipment for this research. And of course, my mom and dad, who've allowed me to put countless numbers of wires into their trees to pursue amateur radio. So when we get started here, let me just mention that this presentation is actually a very brief summary of research that I've been conducting at Purdue University, Fort Wayne over the course of 2 years. So there's a lot there, and we're only able to hit the highlights. But hopefully this gives you an idea on how amateur radio has played a significant influence in the research that I do as a student and into this academic field as well. We'll start with some introductions. This is myself. I just completed my junior year at Purdue University, Fort Wayne. That's the Fort Wayne branch of the Purdue University system. I am majoring in music and an outside field, so I came to amateur radio via perhaps a slightly different route than some of you. I was first licensed in 2012 as KC9 vehicle registration number. Thanks to the encouragement and assistance of my mentor and older brother, Chuck, KC9 IPR. We hit the upgrade trail, got the general, head up to amateur extra in April of 2013, and the rest, they say, is history. I started as a QRP only, CW only operator with a little MFJ 9340W Cub. And of course, like most things in amateur radio, you can't stop with just one radio. You need to expand. So we've added various pieces of equipment over these years, and just absolutely love the hobby. We do some work with different local clubs, including my local radio club. We're a member of the Fort Wayne Radio Club, the W9TE, Fort Wayne DX Association, CW Ops, Straight Key Century Club, North American QRP Century Club, and of course ARRL. And when we do get time to do stuff with amateur radio, which isn't often during the semester, we're doing CW, Parks on the Air activation or chasing, DX, some contesting. Just really enjoy so many elements of amateur radio, and there's just so much to explore. You never get bored. So that's a little bit about me. Let's actually dig into what you all came here for and the actual presentation. So the research I've been conducting is centered on trying to find ways of improving the field of wildlife telemetry. Before we can get into the actual research, we have to look at one of the core tenets of wildlife telemetry, which is radio direction finding. In amateur radio, we know radio direction finding more commonly by the term fox hunting. I'm sure most of you know what fox hunting is, but in case you don't, fox hunting is simply an activity where you will take a simple directional antenna, some kind of receiver, and some sort of compass or means of telling your direction, and you will attempt to locate a transmitter and identify its exact location. Has a lot of practical applications, spurious transmissions, intentional interference. It's a very useful skill and one that radio amateurs have been pursuing for many years. It obviously, in terms of radio direction finding, has a lot of military, government, espionage applications as well. One of the first successful direction finding systems was established and patented in 1902 by the American scientist and inventor John Stone. Lee DeForest, a very famous name, came along in 1904 with a new system, which we still use some tenets of that system in radio direction finding today. That, of course, improved in terms of functionality and ability all the way through to the First World War and the Second World War, particularly Second World War, when you saw a very dangerous, very deadly game of cat and mouse between the freedom fighters within Europe being hunted down by the Nazis and trying to get messages out of Europe prior, of course, to those D-Day landings. And then, of course, the Cold War, which was a very big innovator in radio equipment, sort of the era of the spy novel and everything. In fact, the photo that you see here right now on the slide is a relic of the Cold War. That is known as the Elephant's Cage. It's a directional array that was established by the US military across the globe for use in direction finding. Massive setup, dozens of antennas inside that one array. So you can see that radio direction finding, it's very serious. It's something that's been going on for many years. But for us radio amateurs, usually it's just something that we do as a fun activity. Now, talking about wildlife telemetry and how this relates. So wildlife telemetry is essentially the same thing as radio direction finding. There is very little difference between the two. In the case of wildlife telemetry research, the goal is not only to establish an exact location, it's to use that location to understand and evaluate the condition of animals. This has been going on since the 1900s. Around the 1950s, you're going to see several scientific publications start popping up of researchers using wildlife telemetry to inform them and guide their research into wildlife conservation, wildlife preservation. They use very similar equipment to radio direction finding. With a wildlife telemetry setup, what you're going to do is you're going to attach a very light transmitter, usually via temporary collar or harness, sometimes glue, to a particular species. You're then going to take your receiver and your portable directional antenna, and you're going to use that setup to track the movements of that animal. Maybe you're just tracking the movements of the animal. You might be actually trying to pinpoint the exact position of the animal. But in any case, you're using this technology as a baseline to establish how is an animal behaving, how are environmental factors affecting its behavior, how can we use this information to guide environmental policy. So simply put, wildlife telemetry is a research tool that you're going to use to understand wildlife behavior, and it all centers upon radio direction finding. The equipment used between fox hunting and wildlife telemetry is incredibly similar. Fox hunting, we use 3-element tape measure Yagi antennas. Maybe you use a quad, maybe a 5-element Yagi if you're really going great guns. You'll see here on the slide in front of you a picture of a 3-element wildlife telemetry Yagi. So it's just your standard Yagi with a small gamma match and your driven element. This is an antenna currently used by PFW researchers. Very similar to what we use in fox hunting. Receivers are also very similar. A conventional wildlife telemetry receiver will use the double conversion super heterodyne receiver. They may use software-defined radios as well. It depends. Those aren't as common. Transmitters are very common between fox hunting and wildlife telemetry. In the case of fox hunting, usually fox transmitter, you may start out with a very high-powered transmitter. Once the hunters arrive at the site and they found the main fox, you may extend the exercise even further and have very low-powered foxes called microfox transmitters. In wildlife telemetry, frequently, the transmitters in use are like those microfox transmitters. They're very light. There are guidelines on how heavy those transmitters can be. They have to be battery powered. Some of them are very technologically advanced. They include GPS receivers into the transmitter. So it's sort of like a transceiver, but it will include the GPS data in the transmission. Other transmitters are super, super simple. They include just a simple continuous wave CW carrier that it will beacon out at regular intervals, similar to how we might have a 10-meter beacon or 6-meter beacon. Same exact idea. So again, bear in mind, fox hunting and wildlife telemetry are the same things. They just have different end goals for what they're trying to achieve. Now, how exactly did I get involved in wildlife telemetry, and how did this project come into being? There were sort of two distinct influences. One is my older brother, Chuck, KC9IPR, as a graduate of Purdue University, Fort Wayne, with a degree in biology. And he participated in some wildlife telemetry research. In their particular case, they were looking at turtles in a local conservation area known as Eagle Marsh. And he would come home and he would tell me about the different stuff they were doing and the technology they're using. And that sort of piqued my interest about what it exactly was they were doing. Then I ran into an old school television show known as Mutual of Omaha's Wild Kingdom. Now, this show was sponsored by the insurance company, Mutual of Omaha. It was hosted by Dr. Marlon Perkins, who was the director of the St. Louis Zoo. He also was in Chicago. Just a wonderful, wonderful personality, great guy. A lot of big names in wildlife and environmental research. Jim Fowler, Stan Brock, Peter Gross, who is still alive. Actually, I believe Jim Fowler just died about 2 years or so ago. And I found a bunch of reruns of the show on YouTube. And this was really quite intriguing because if you are any at all interested in animals or technology, you will see wildlife telemetry play a very featured role in some of these episodes. So the combination of the work my older brother was doing and seeing this show really got me curious as to what they were doing in terms of radios and technology, because I was licensed at the time. I wasn't in college, but I was licensed. And I was thinking, you know, this is a really cool avenue for amateur radio. You'll see the picture on your right. That is the TRX 2000 WR, WR standing for water resistant. This is one of the receivers used by PFW wildlife telemetry researchers. It's manufactured by Wildlife Materials. It looks fairly simple. You'll see some familiar controls from your typical amateur radio set. Spot for your headphones. You'll see a band switch button, an attenuator, a few other things. This is actually battery powered. It's rechargeable. It has a limited frequency range, about 150, 151 megahertz, thereabouts. It depends on what it is that you want. And it's a really interesting device because if you watch the Mutual of Omaha Wild Kingdom episodes and you see the kind of receivers they are using, they look very similar to this TRX 2000 WR. That leads me to two different conclusions. Conclusion number one, it's a really good design. They've been using it since about the 1960s, 1970s, when Wild Kingdom was being aired on TV. They continue to use it to this day, so it has roughly a 60-year run of this kind of design. I'm sure there's been improvements, but it's a very similar aesthetically the type of device. It also means that the field is beginning to open up in terms of wildlife telemetry and technology. Software-defined radios are starting to enter wildlife telemetry. Drones are becoming an element of wildlife telemetry. So the field is very exciting to see what all you can use with technology. I entered college in fall of 2021. And in spring of 2022, I began talking to Dr. Jordan Marshall, the member Mike 9 Lima, and say, hey, could we do a research project on wildlife telemetry? And since we're both amateur radio operators, we naturally fell back on our amateur radio experiences to see how could that apply into the field of wildlife telemetry. Wildlife telemetry has several significant challenges involved with it. One challenge is that the cost of equipment is quite high. That receiver that I showed you, the TRX 2000 WR, will probably cost you roughly $1,000. I've seen something as low as around 800, but it's going to be about $1,000 or higher for that receiver. And again, that's just a very limited slice of spectrum. If you want to purchase a commercial version 3-element Yagi for use in wildlife telemetry, you are going to be probably paying about $100 to $130 for 3 elements, roughly $200 for 5 elements. Add in the cost of a transmitter, and the costs continue to increase. The transmitter we used was the LB2X, made by Holo Hill Systems out of Ontario, Canada. That transmitter alone will cost you around $235 to $260 a piece. These are usually ordered in batches of around 20 each. They are battery powered. They transmit around, I believe it's 10 to 25 milliwatts of power output. And they only last via battery around 12 days at maximum. So there's a heavy equipment cost. If you have multiple students pursuing wildlife telemetry, those costs will then continue to increase. The other challenge with wildlife telemetry is reliance on audible detection methods. Traditionally, what happens, and this is similar to fox hunting, the way you know if you're pointing in the right direction is that the signal sounds louder. It's a very simple method of detecting a signal. Well, when you're doing scientific research, you want to keep any sources of error to a minimum. And one of those sources of error potentially is the hearing ability. If someone has a level of hearing impairment or hearing loss, you could have two researchers, researcher A, researcher B. They have the same equipment, same starting point, same target transmitter they are trying to receive. But if researcher B has hearing impairment, they may not be able to actually hear that wildlife telemetry transmitter, which means that however much money you spent on transmitters are now totally wasted. You're not going to hear the transmitter, or you're going to spend much longer amounts of time getting data points versus researcher A who doesn't have any kind of hearing impairment. It also means that if you have drastic hearing impairment, you're not going to be able to participate within the field of wildlife telemetry. That's something that here in amateur radio, we have radios with modules built in so that those with vision impairment can't be able to operate a radio transceiver. Very sort of similar thinking here is how do you decrease the source of error, decrease the cost of entry into this field of research, and also lower the level of entry in terms of hearing ability. So eventually what ended up happening is we formed two project goals. Project goal number one was to try to address equipment costs. And we decided to tackle the antenna costs. Particularly, could we design a directional antenna that was less than the $100, $130 charge for commercial Yagi? Could we achieve same or better performance? If we're achieving worse performance than a commercial version, doesn't make sense to use something homemade, even if it is really cool to use. It had to be portable because these antennas are going to be taken out into the field. They're going to be held for hours, perhaps at a time. So you have to keep it very light. And it had to be something someone could build if they had no prior electronics experience. So there's a lot of different goals that we wanted to achieve, but we reserved summer of 2022 to conduct the field tests and achieve, or see at least if we could achieve, the goals of the first part of our study. Our second part of the study, with a second set of goals, was to look and see the possibility of receiving a telemetry signal visually versus audibly. This is probably where you see the clearest direct connection between amateur radio and wildlife telemetry. You may be familiar with this mode some people are using called FT8 that they are running. And it's a really great mode. I have to say I've been using it as well. And it's fascinating what it's able to do. And we're very fortunate to have the software for that mode for free. But you may have noticed when you're making contacts in that mode that you're making contacts you can see visually on the waterfall display on your screen that you can't hear. And Dr. Marshall and I thought this was very intriguing. And we thought, could we take the same idea and apply it to wildlife telemetry? So basically an FT8 approach to telemetry reception. In our case, what we are defining as visually detectable, we are looking for traces of a telemetry signal in our waterfall display. And we're using software-defined radios in order to create that waterfall display. And of course, connection to some kind of computer and additional ancillary devices to set up those software-defined radios. So starting with summer of 2022, we'll kind of look through the different equipment that we developed before we and utilized before we look at conclusions, what we were able to find. We started off with the antenna design. Particularly, I was using the software program that's free to download for NEC2. You may be familiar with that software program. It's great free software for antenna experimentation, antenna design. Of course, now we have Easy NEC as well, which is free software. And the design goal was to see, all right, we're going to start inputting different designs, see what we can derive, and see if there's a way of increasing the level of performance. We took the dimensions of the current commercial Yagi, inputted those into 4NEC2, try to get an understanding of how that antenna performs, so that when we go to design the newer antenna and new versions, we could try to mimic that performance. Our final design that we arrived at is the tape measure Yagi. I'm sure the patent must be pending on this device. This is actually one of 3 designs that we ended up building. Sake of time and space, we didn't put up all 3 designs. First design we had made out of aluminum tubing from the local big box home improvement store. That actually was cut and drilled by one of the labs on campus, and it utilized 3D printed mounting brackets for the elements to the boom. Those were actually designed. I helped design those and printed on campus at our 3D printer lab. And a super easy way of getting mounting brackets exactly the size you need. We also looked at tape measure Yagi designs. The picture you see in front of you is the second version of the tape measure Yagis that we accomplished. This version is slightly scaled from the common 2-meter tape measure Yagis that you'll see in online and YouTube videos. This is designed for a frequency of around 151 megahertz. It's this particular version we tried to design for maximum gain. You'll notice a small black object on the antenna leading to, with a couple of leads to that driven element. That is, again, another 3D printed bracket that was printed by my mentoring professor, Dr. Marshall. It's made out of PETG material. We avoided PLA because we didn't want to deal with the low melting temperature of PLA. So we went with the PETG material. And it's a simple BNC chassis mount connector. Antenna worked really quite well, but again, we'll get into that in the results and conclusion. Sticking with our theme on low-cost wildlife telemetry. This started in summer of 2022. We had a very low cost. I think we were using an RTL SDR dongle. You can find those on Amazon, other internet sites. Roughly $28, $30. Sometimes they come with more accessories, and they go up to around $60 for that. But in our case, we had the low-cost version. We ran free software, SDR Sharp, which is a free download. And we basically did a proof of concept test, which was, could we receive a telemetry signal? Remember that some wildlife telemetry transmitters are very simple, and they basically consist of nothing more than a CW beacon is really what all they are. It's probably a little difficult to tell Perhaps my cursor can help illustrate some of this, but you see right where the cursor is pointing is one of the it's a telemetry signal. In case of our 2022 research, we were actually using a beacon versus an actual transmitter. It's what we had on hand and what we had access to at the time. That beacon is used by wildlife telemetry researchers as a point of reference. So when they're out in the field in the middle of the woods, they can set that beacon up in a known location. They know what direction that is. They can hunt for the actual transmitters on the animals. And then the difference in the received direction between your beacon and your animal helps pinpoint your location and guide your research. But this is what we started with. This was the start of visual reception of wildlife telemetry, again, based on FT8, Whisper, some of those digital modes. Fast forward a year to summer of 2023, and we received the scholarship from the PFW Honors Program to further our research into the visual reception aspect. These SDRs are probably very familiar to you. They frequently pop up in amateur radio circles due to their performance and cost. On the left, you see the UK-made SDR Play RSP Duo. The RSP Duo is a wonderful software-defined radio. It has dual tuners. It has the ability for diversity reception. So if you want to try to do some noise canceling and try to improve your signal-to-noise ratio, very wonderful device to do it. That runs on, again, free software made by SDR Play called SDR Uno. On the right, you see the AirSpy R2. I believe this is made in China. This runs, again, free software. We used SDR Sharp because we were familiar with it. The difference between these two devices, other than cost, is that the SDR Play is a true DC to daylight receiver. AirSpy R2 is VHF above and above. You can get converter units for the AirSpy R2, so you can also receive HF and lower frequencies. But in its natural state, the AirSpy R2 is just going to be VHF plus. So these are really terrific receivers. Your SDR Duo, or RSP Duo, excuse me, is going to be around $289 is how much we paid for that one. The AirSpy R2 is around $130, $160. We also bought some actual wildlife telemetry transmitters in 2023, which were the LB2X by Holo Hill. Now, to actually conduct the research, this is a screenshot of Google Earth on the west side of the PFW campus. You'll see the river running there along the west side. That's the St. Joseph River. You'll see the science building here in the upper right corner, as well as one of our other main classroom buildings there to the southeast corner. This is the area we conducted all of our tests, 2022, 2023. In the case of 2022, it was a fairly simple test. We would take one of our Yagi designs, connected to the Wildlife Materials TRX 2000 WR receiver, and then perform A/B comparisons between that handcrafted Yagi versus the current commercial 3-element Yagi. Take recordings of and record how strongly we are hearing the beacon signal, and that would give us a pretty good idea of how close we were in performance. In the case of 2023's research, it was a bit more involved. In our field experiments, we were aiming to see visual reception, and is there a difference between a visual reception distance versus an audible reception distance with a software-defined radio? How do you determine that? You take an LB2X transmitter, carry it out a certain distance into the field. You will get a GPS coordinate for that transmitter site. At the receiver site, which is also GPS located, you will take your software-defined radio, turn everything on, engage in screen capture and screen recording that is running in real time as you're conducting the test. And then you will hunt for the wildlife telemetry transmitter signal. That's one of the benefits of software-defined radios. You can do those screen recordings. It's not like a conventional receiver where you're going to have to physically use a camera to try to record what you're seeing. With a software-defined radio, you can just use any kind of screen capture software, make those recordings, save them to either your laptop, external hard drive, and you'll be able to go back and review the data however many times that you may want to. So speaking about visual reception, this is what a wildlife telemetry transmitter signal looks like. In this case, we have a screenshot image of SDR Uno being used in coordination with the RSP Duo. There's multiple windows within SDR Uno, so you have to kind of choose what you want to capture. Maybe you want to do a full screen capture. In our case, we chose to capture the waterfall display. So here's our waterfall display. You see on the left-hand side of the screen, you've got readings in dBm, reference to dB of milliwatts. You'll see these parallel red lines. These are actually what you need to control your filter bandwidth. So rather than have an actual filter setting programmed into the radio, you can just click and drag these parallel red lines to increase or decrease your filter bandwidth. You'll notice these 4 bright dots, a little bit pinkish orange color, as well as a deep blue background. That deep blue background is just like an ICOM 7300 or 9700. That is your background noise. The actual repeated dots are your transmitter signal. This is one of those CW beacon style transmitters. It's transmitting at a regular interval. You can hear this. At this point, the signal is strong enough that you are audibly receiving that. It shows up very nicely with SDR Uno. I have to say that SDR Uno is really one of the best SDR softwares that I've used. It's very well thought out, a little bit tricky to install, but it is really great to use. Compare that to the AirSpy R2. This is running SDR Sharp. Again, you see a variety of controls like your mode selection on the upper left. It has in some ways a more approachable user interface than the RSP Duo with the SDR Uno software. You cannot see it as clearly, but we are receiving that LB2X transmission here in the center of your screen. You'll see this red line running down the center of that sort of spectrum waterfall display. And you'll notice there's a series of yellow dots. You might have to get right up to the projector screen to see this, but hopefully the recording will capture this. Again, those are your regularly repeated transmissions from the LB2X transmitter. And when you're doing visual detection of wildlife telemetry signals, this is exactly what you're looking for. You're looking for some deviation from that blue background noise, and you're looking to see that repeated intervallic pattern coming from the transmitter. Now, to get to results, it was a mixed bag. Starting with 2022 and what we accomplished with the handcrafted antennas. We were not able to match the performance of the commercial 3-element Yagi with our designs. That being said, we got very close. By the time we'd hit design number 3, or the second version of our tape measure Yagi, the difference between the 2 antennas was really quite small. I have to look and see, our records for that, but it was surprising at how well just some pieces of tape measure and some PVC pipe are doing compared to this commercially sold and designed antenna. That really seems to indicate, your commercial, your handcrafted Yagi can, and other directional antennas can compete with commercial antennas, but it's going to take careful design. Now, we did accomplish a much lower cost. The tape measure Yagi was designed using store-bought parts. We did not use anything from the junk drawer or sitting around the garage. It had to be something designed from the big box store, so that if another researcher duplicates what we're doing, they can go to the store and expect to pay the exact same amount, or at least close to that exact same amount from wherever they are. Tape measure Yagis cost us about $24 total. The handcrafted aluminum Yagi cost around $60. So compare that to the 130 of a commercial 3-element. It's really quite, we were quite pleased with that. Again, the performance was approaching that. We did not quite equal it, but it was really encouraging. By the time we had finished the test with the second Yagi, we were getting to the end of the summer, and I had to start preparing for the next semester. But we were encouraged by that. Visual reception results were very intriguing, at least for us. Number one, we have to acknowledge the fact that not all SDRs and SDR software are created equal. It's just the nature of the beast in technology of how something is implemented, how the controls are situated, how the design was done. In our case, we were able to determine that you can visually detect a telemetry signal. In the case of the RSP Duo, we discovered that the audible reception distance and the visual reception distance are about the same. In our case, we were picking up that LB2X transmitter at distances up to around 1.7273 kilometers consistently. Intermittently, we could get up to around 1.78, 1.79 kilometers. The AirSpy R2 kind of struggled. We got reception distances up to around 600 meters, thereabouts. But once we exceeded that distance, it pretty much would not return any visual results. Is that because of the difference between the SDRs? Is that the difference between the two different kinds of software packages? With all of our tests, we are running on the exact same laptop, exact same system. So, I mean, there's room for expansion and investigation there. But we were quite pleased, particularly since that purpose-built receiver by Wildlife Materials had a receive distance. We tested a maximum of around 1.9, 1.93 kilometers. So in effect, you're basically paying $1,000 for a unit that can receive approximately 100 to 200 meters further than something that we use in amateur radio frequently, like an RSP Duo, which is going to cost you around 300. So you could buy 3 RSP Duos, send out students or other researchers with those Duos for the cost of one Wildlife Materials receiver. So we were quite encouraged by that. The visual reception distance matching the audible reception distance was also encouraging. It means that you can legitimately track something visually without ever having to hear that signal audibly. Now, how does this tie into again, the greater scope of amateur radio? Honestly, amateur radio was, and the experiences that we have had, Dr. Marshall, myself, and amateur radio, was the backbone of this project. If we had not had the experiences in amateur radio, learning about what is a noise blanker, what is a gain control, how do you adjust filter bandwidth, what's a software-defined radio, if we had not had those experiences, this experiment would have been much tougher to accomplish. Amateur radio is like a giant science experiment with everything that we get to do. We've got so many different modes, so many different facets of the hobby with which we can experiment. We know how to incorporate both old and new technology to accomplish something that's even better. And we also know how to use open source software to accomplish a solution that may cost thousands in the commercial market. So in this case, we were looking at wildlife telemetry. How does the experiences and techniques we're using in ham radio apply to wildlife telemetry? But amateur radio has a lot more to offer. It has many more features and training methods that would fit perfectly with a variety of academic disciplines, commercial research, government applications. It's one of the best training grounds you're ever going to have for a career in communications or just general knowledge. So really, I would say that this experiment is just another example of how amateur radio can apply to academic research, and to general scientific knowledge in general. So thank you so much for having me. I appreciate it. That's the end of my presentation. Bill and Kevin, I don't know how you want to handle any questions, if there are any, but we're happy to answer what we can.
Did the SDRs, did you incorporate the cost of the computer if they were hooked up to the SDR?
That's honestly a really great question. In our case, we didn't incorporate the cost of the computer into the SDR, namely being because, number one, if you are conducting research with a university, chances are very good that you will have access to some kind of computer that can be either loaned from the IT department or something of that nature. Secondly, because laptops have become so prevalent in society, as well as smart devices, it's for us, we estimate that it's going to be very, very likely that anyone conducting wildlife telemetry research will have access to some kind of device or laptop in order to accomplish those goals. So we didn't incorporate the cost, but I sort of think it's sort of a sliding scale. You also incorporate costs of vehicle transportation, hourly pay if you're maybe a part-time worker. So we assume that someone owns the computer before they begin the research.
All right, I'm not seeing any other questions at the moment. Oh, we got another. Art, go ahead, and then I saw your hand too. Did you experiment any with the transmitter side of it?
It's another great question, actually. We did not experiment with the transmitters at this point. Neither Dr. Marshall or myself are engineers, and these transmitters are so incredibly tiny that it is going to be difficult to experiment with them. For example, an LB2X weighs in the grams. It's designed actually for what Dr. Bergeson uses these transmitters for, is for research on bats. So they actually will capture bats. They will use a non-permanent glue, and they will glue them onto the bat. Eventually that glue will harden and the transmitter will fall off. So they are probably about the size, about a quarter to maybe half the size of your small fingernail is the size. But that's also something we like to experiment just to see if maybe could cost be lowered by using a different kind of transmitter or another design. It's a really interesting aspect of research. So yes, absolutely would love to experiment with those transmitters. They're just a very small form factor. I think you need more expertise than we have to do that.
So the next question was, have you actually tracked an animal, a species, some type of critter?
So I personally have not engaged in that. I've been mainly working on just the technological side of it. I could say my older brother, Jason at IPR, actively engaged in tracking turtles. Snapping turtles can be quite opinionated when they are being tracked and transmitted attached to them. He has several stories on those. But no, personally, I have not actually tracked the animals. In order to do that, to participate in that research, you either have to have a project that's ongoing, or there are sometimes, depending on the animal and the project, sometimes you need additional approval and perhaps a rabies shot in order to participate in that element.
How about the output power of those transmitters?
That's a great question. As far as I know, and I was actually looking for that exact information on the power output of the transmitter itself. I believe it was around 12 to 25 milliwatts. We did not actually do a power measurement with any kind of like RF meter. But again, these are running off of a single sort of like one of those small nickel batteries. Some of the smaller ones, you'll see like a stack of 3 or 4 to power a small LED pen light. A single one of those batteries is used for the transmitters. But again, I believe it's around 12 to 25 milliwatts, but I'd have to double check on that.
The question was, did you receive any grants from the federal government for any of this?
I would have absolutely loved a federal grant. No, we did not receive any federal funding for this. When we originally began our research, we did not realize we were going to be at it for about 2 years. Originally, it started just as a project to do over the summer and see what we could do. And as we got further and more involved, we eventually began to expand the project and seek some funding. We did have some initial funding when we began the 2022 research from Dr. Marshall's laboratory. But other than the PFW honors program, that was the only funding we had for this particular project. Would have been great to have federal funding. Definitely not going to say no, but not for this project.
I guess follow up to that was, did you get any state funding? And I'm guessing no.
No, unfortunately not.
All right, I think that is it. Oh. All right, thank you very much, Jim, for doing your presentation.
It was great.
Everybody, you've got people, they don't realize I don't have the, oh, yeah, you do have the camera there. That's the group you were talking to there. We managed to flip one of the laptops around. Thank you very much, and I want to thank Kevin. He's the one who technically set it up where we had to run 2 laptops, one for video, one for sound. This room doesn't always cooperate with us, but thank you again. And we're going to transition to our regular meeting.
All right. Thanks so much for having me. It's been a real pleasure, a real honor to come there. And definitely thank Kevin there for setting everything up and everything else. That's ham radio in action there. One thing I should mention too, if you have more questions and stuff on particularly anything in the presentation or something like that, definitely shoot me an email there. It's included there on the slides. If you're interested in the transmitters for additional research on that, look up Lima Bravo -2 X-ray. You'll see you can look those up. Very simple antenna, actually. It's like maybe 5-6 inch long, a very thin wire. So I don't believe it's actually a resonant antenna, but those are some areas you can check that out. But always feel free to drop us a line. And thanks so much for having me. You folks have a great week, and thanks for having me.
Thanks again. Take care.